Okay, W plus or minus delta W, 3.04 plus or minus 0.01. P plus or minus delta P is 1.03 plus or minus 0.01. So measurement, uncertainty, and propagation. The last lecture we went over sig figs, and we dealt with if we multiplied W and P, or added and subtracted W and P, or divided W and P, or P and W, and so on and so forth. But now we need to talk about what happens to delta W and delta P. Okay, those are going to be our measurements. So, first case that we can have is if we have W plus or minus delta W plus P plus or minus delta P. I'm going to add two values together. The result is going to be W plus P plus or minus delta W plus delta P. In this case, add the numbers, add the numbers. So we get 4.07 plus or minus 0.00 or 0.02 meters, centimeters, milliliters, whatever you would have. Okay, if we subtract W plus or minus delta W minus P plus or minus delta P. In this case, it's going to be W minus P plus or minus delta W plus delta P. They still need to be added because you're doing an operation. So the worst case could have been 0.01, and the other one, you have to add the potential errors that you're going to have in your measurement values. That's going to be the propagation of uncertainty when you do calculations with your measurements. This results in 2.01 plus or minus 0.02 is again going to be your uncertainty. You're bounding your uncertainty because this could have been 0 and this could have been 0. Or it could have been negative 0.01. You could have been a little bit off from that value. So again, this value could be 1.00 or 1.04 or 1.02. It's somewhere in between that. So you say 1.03 plus or minus. Could go a little higher or a little below what your measurement is going to be. So then, in this case, the additive. So you could be 0.02 off, or point higher, or 0.02 lower. That's how the error is going to propagate. Now if we take W plus or minus delta W times by P plus or minus delta P. You'd have to FOIL this out, but we'll make a simplification and approximate it to the result of W times P plus, or 1 plus or minus delta W over W plus delta P over P. Okay, the result of this, by our example, is you get 3.13, 1 plus or minus, and the result of doing this operation gives you 0.012998. Now I'm leaving the number long in there because now I still have to multiply that through. Results in 3.13 plus or minus 0.04. Multiply that through and round up to the second digit. Now we could also have division. W plus or minus delta W divide by P plus or minus delta P results in W divided by P, or multiplying through plus or minus delta W delta P over P. So delta W over W plus delta P over P. Doing this operation results in W over P is 2.95. 1 plus or minus, again, 0.012998 results in 2.95 plus or minus 0.04. Some other operations that we can have is if let's take a square root of a measurement. So if you have W plus or minus delta W, we want to raise this to the 1/2. This results in W to the 1/2 plus or minus delta W over 2 W to the 1/2. Or this could also be thought of as the square root W plus or minus delta W, square root of W plus or minus delta W over 2 square root of W. The result of this would be, using these numbers, 1.74 plus or minus 0.003. And the last operation that we'll go over is if you square it. W plus or minus delta W squared. So this would just be this process here, but replacing P plus delta P with W plus delta W. And then just doing all the swap. So this is WW or W squared plus or minus delta W over W plus delta W over W, delta W over W, which is 2 delta W over W, and the result would be 9.24 times by 1 plus or minus 0.00658, doing a rounding 9.24 plus or minus 0.06 for that calculation. Okay, that concludes the lectures on error and measurement uncertainty propagation.